Hello, my name is Alberto Pascal, and today I will be sharing with you my traffic solution. Some background is we want to train the AI to identify traffic signs, and the data is given to us in the form of ppm images as shown below. So we need to use the CV2 module to analyze them. When loading data, therefore, we need to scan the directory, and for every image, read it, resize it, append it to an array, and store the label that is the root directory of that image. Finally, we return the tuple of that information. And for the model itself, we will use TensorFlow's Keras module to create a sequential neural network. And we want to test out with different convolutional pooling and hidden layers, compile the network, and return the compiled model. So before going on with the program, I want to mention about my starting testing process. I started by having a neural network based on the glasses example, having one convolutional layer of 32 filters, 2 times 2 max pooling, flattening 128 neurons in a hidden layer, 50% dropout chance, and the output layer with softmax activation, which led to a 62% accuracy. And from then, I started making some changes to see how could it improve. So here it is. Let's run my code. Right now, it is going through the directories to scan the images and learn about the images given as an input. Within my testing processes, I first started by trying out different number of hidden neural layers. I saw it had a slight improvement, so I tried playing around with the sizes from the convolutional layer and the max pooling layer. I increased their size, but I also noticed that increasing their size also meant that it would decrease the accuracy of my pixels. So, as expected, it had much less accuracy. So I then tried adding a second convolutional layer. I added a second hidden layer and a second max pooling layer, which bumped up my accuracy quite a bit. And from there, I started playing around with the dropout, which I noticed that increasing the dropout too much or decreasing it too much was also not beneficial for my results. I played around with a third convolutional layer, which also made my accuracy much, much worse, going from around the 90% to a 5% only. And I think this was mostly due to the fact that I had too many limitations on my pixels. And finally, I played around with the activation functions, changing them from ReLU to SELU, and I noticed it was basically the same. So I combined them, and I have a first convolutional layer with a ReLU activation, and the second one with a SELU activation, which ended up having or relating to the best possible results here with my accuracy. As you can see right now here, my model is having uh, pretty big jumps in accuracy. In only the sixth epoch, we're already at 77% accuracy. Um, what I noticed most of the times is that my code usually ends up around from 93 to 96, 97% accuracy, which I think is pretty nice. My final model only has 2 convolutional layers. It has 2 max pooling layers. It has a single hidden layer with uh, around 256 neurons. And also something I changed and play around with was the number of filters used in the convolutional layers. So instead of using 32 filters at first, I started using 64 filters in the first one, reducing it to 32 new filters in the second one, which I think also helps a bit in expanding my frontier or my boundaries of where I can look for in the data. So we're almost done. We're on the last epoch. As we can see, the accuracy is not doing that great right now. But I noticed also that it jumps once it ends, it jumps again. So I noticed this big change when handling the cello activation. And as you can see, even though the last epoch resulted in 84% accuracy, the overall results ended up being a 95% accuracy with only a 0.1983 loss. That would be it. Thank you for watching and see you all next time.